Alright, so today we're going to have a look at Year 11 Advanced Logarithms. So, logarithms are all about the relationship between an indice and also the inverse operation of a logarithm, much like that multiplication is the opposite of division. Some important things to note are our 4 logarithm rules from Year 10. So number 1, the product rule of logarithms. Log base a of xy, so timesing together, is equal to log base a of x plus log base a of y. Then we've got the dividing the quotient rule of logarithms. Log base of x on y, log base of a of x on y is log of x minus log of y. Our power rule states that if I have a power that my logarithm is subject of, I can bring the power down. So log of a to the power of x is equal to x log a. And finally, and there are more logarithm rules than this, but these are the 4 most important ones. Log base a of a is equal to 1. We're going to start down here at question 3. We've got let a equal e to the x, which expression is equal to log base e of a squared. We might note that log base e has a more common form, and we say ln, or the natural logarithm. And we're told in this question log base of e, a is e to the x, so a squared is e to the 2x. Using our power rule of logarithms, we can bring down the power, and it's log base e of e. We're bringing this power down to here. Log base e of e, using that 4th rule over here, log base of itself, so if you've got the same thing here and here, it's equal to 1. So we've just got 2x times 1, so the answer is 2x. Number 4, we've got what is the solution of 5 to the power of x is equal to 4? Using our transformation of logarithms, the power becomes what it's equal to. Log, the base of the original indice becomes the base of my logarithm, and it's subject 4, so log base 5 of 4. Now we might notice that none of those are the correct option. We can see that all of these answers are of base 2. So we're going to use our change of base rule to change the base of this logarithm to 2. And we do that by doing this. We choose the new base of 2. Now this process is the same no matter what base you choose. More commonly we'll choose the base base e, which is ln for the natural logarithm. In this instance they've chosen base 2. So we choose our new base, it goes here. The original 4 goes here, and the original base goes down here, and we can see that's option C. Question number 6, we've got what is the solution to the equation log base 2 of x minus 1 is equal to 8? Using our transformation of logarithm rule, we'll notice that x of a to the x is equal to b. X is going to be log base a of b. So going back the other way, we've got log base 2 of x minus 1 equaling to 8. Transforming that in the other direction, the thing in the brackets, which was our b, is now what it's equal to, x minus 1. The 2 is now the base of my indice, and what it's equal to, the x, is now the power, so 8. Now 2 to the power of 8, what's that, 64? Let me double check. Sorry, 256. X minus 1 is equal to 256, plus 1 to both sides. We get x is 257, and that's option D. Question number 11, we've got solve the equation e to the 4x minus 5e to the 2x plus 4 is equal to 0. To do this, we're going to use a u substitution, and we're going to say let u equal to e to the 2x. Now, e to the 4x is e to the 2x squared. So we can say this is equal to u squared minus 5u plus 4 equals 0. That will factorize and give u minus 4, u minus 1 is equal to 0, which means u is equal to 4 or 1. However, we've stated that u is equal to e to the 2x. So e to the 2x is equal to 4, or e to the 2x is equal to 1. To solve this, we're going to take the natural logarithm of both sides. So ln of e to the 2x is equal to ln of 4. Using our power rule, we bring down the 2x and say this is 2x ln of e is equal to ln of 4. Now ln of e is 1, so 2x is equal to ln of 4. Divide both sides by 2. X is ln of 4 over 2. Now we can continue to simplify this, and we can see they've unfortunately done that in the question. X is equal to ln, well 4 is 2 squared, so 2 squared on 2, bringing down the power. X is 2 ln of 2 on 2, which is ln of 2. So that's one of our solutions there, ln of 2. E to the 2x is equal to 1. We're going to have a go at solving that now. Taking the natural logarithm of both sides, ln of e to the 2x is equal to ln of 1. Now ln of 1 is equal to 0. If you type that into your calculator, ln of 1 is equal to... Oh, actually, no. ln of 1 is not allowed. Sorry, yes it is. ln of 1 is 0. So that just means x has to be 0. ln of 1 is 0, so x has to be 0. So the answer is option C. Okay. That's not a logarithm one. We'll do this one. Solve the equation log base e, so ln of 3x plus 5 plus ln of 2 is equal to 2. We're going to use our rule of addition of logarithms. When we add logs of the same base, that's the same as saying multiplying them. So this is ln of 6x plus 5 is equal to 2. The way we solve these is by raising both sides to the e. So e to the power of ln of 6x plus 5 is equal to e squared. If you raise e to the power of the natural logarithm, these just kill each other because they're the inverse operations, kind of like a plus and a minus cancel and become a minus. So this just leaves 6x plus 5 is equal to e squared. We just subtract 5 and divide by 6. X is equal to 1/6 e squared minus 5. Okay, question 17. We've got 2 to the power of 2x plus 1 is equal to 32. The way we do this is by taking the natural logarithm of both sides. ln of 2 to the power of 2x plus 1 is equal to 32. Using our power rule, is equal to ln of 32. Using our power rule, we can bring down the 2x. ln is to bring down the 2x plus 1, multiply it by ln of 2, and that's equal to ln of 32. Now we might notice that 32 is equal to 2 to the power of 5. So we can replace this with 2 to the power of 5. So 2x plus 1 times by ln of 2 is equal to, bring down the power, ln of 2. We can cancel ln of 2 from both sides, and we've got 2x plus 1 equals 5, which means x is equal to 2. Use the change of base formula to evaluate log base 3 of 7. Now we can change the base of a logarithm to any base, but generally we choose the natural logarithm. So we're going to say that this is equal to ln of 7 over ln of 3. So we've gone, the thing that log is the subject of, the big number, is on the top, and the 3 is on the bottom. We can type that into our calculator. If you've got a new Casio, you can also just type the original question into your calculator. We get 1.77. Of course, though, this question is asking you to show the change of base formula, so you'd only use your new Casio to confirm your answer. Okay, we're solving the equation 2 log of base 3 of 5 minus log base 3 of 2 plus log base 3 of x is equal to 2. Again, we're just going to use the rule that when first of all we subtract, we divide. Before we do that though, we might deal with this 2 because we can't combine these in their current form because of this 2. So we're going to use our power rule and say this is log base 3 of 5 squared minus log base 3 of 2 plus log base 3 of x, and that's equal to 2. We're just going to use our divide and multiply rule. So we're going to go 5 squared divided by 2, because there's a minus, times by x. So this is log base 3 of 5 squared divided by 2, so 25 on 2 times by x, and that's equal to 2. Then we're just simply going to use the rearrangement of logarithms. So we might remember that a to the power of x equaling b, x is equal to log base a of b. So going back the other way, we're going to say 25 on 2x is equal to 3 to the power of 2. Rearranging that, we're going to go 9 times 2. X is going to equal 18 on 25. Again, I just flew past that because this video is not about your equation solving skills, but you're about your log skills. Question 20, we're solving log base 2 of 6 minus x minus log base 2 of 4 minus x is equal to 2. Again, we're dividing, so all I have to do is, we're minusing, so all I have to do is divide. So this is log base 2 of 6 minus x on 4 minus x, and that's equal to 2. Okay. What we're trying to do is, well, first of all, we can just again transform this. So we're going to say, okay, 6 minus x on 4 minus x is equal to 2 to the power of 2. So that means 6 minus x is equal to 16 minus 4x, timesing this up to here, which means that's going to be 3x is equal to 10, and x is 10 on 3. Solve the equation 2 to the power of 3x minus 3 is equal to 8 to the power of 2 minus x. To do that, we're just going to take the natural logarithm of both sides. So ln of 2 to the 3x minus 3 is equal to ln of 8 to the 2 minus x. Bring down the power from both sides. 3x minus 3, ln of 2 is equal to 2 minus x, ln of 8. We're then just going to expand. It's not going to be pretty, but we're going to expand this here. So we've got 3 ln of 2x minus 3 ln of 2 is equal to 2 ln of 8 minus x ln of 8. So of course we're just going to have x outside of 3 ln of 2 plus ln of 8 is equal to 2 ln of 8 plus 3 ln of 2. And then just going up here, x is going to be 2 ln 8 plus 3 ln 2 over 3 ln 2 plus ln 8. That was fun. Solve the equation ln of x is equal to 2. To do that, we raise both sides to the ln of we raise both sides to the e, so ln of e squared. These cancel each other out, so x is equal to e squared. We might have a go at solving this equation here. Solve the equation, we might write this as ln of x minus 3 on ln of x is equal to 2. Alright. We're just going to times the ln up like that. Ln squared of x minus 3 is equal to 2 ln of x. So ln squared of x minus 2 ln of x minus 3 is equal to 0. And then we're just going to use a cute little u substitution. So we're going to say let u equal ln of x. So we've got u squared minus 2u minus 3 equals 0. Factorising that, u minus 3, u plus 1 is equal to 0. So u is equal to 3 or minus 1. However, we've said that u is equal to ln of x. So ln of x is equal to 3 or ln of x is equal to minus 1. To solve that, we raise both sides to the e. So e to the ln of x is equal to e cubed. They die, so x is equal to e cubed. And then again, e to the ln of x is equal to e to the minus 1. So x is equal to e to the minus 1, or 1 on e. Okay, we'll have a go at solving this equation here. First of all, we've noticed that we've got the same base and we're minusing, so we're thinking we're going to divide, but we can't do anything until we've moved that 2 up to there. So log base 2 of x plus 5, we're squaring that, minus log base 2 of x plus 9 is equal to 1. Now we can go, okay, this is log base 2 of x plus 5 squared over x plus 9, and that's equal to 1. Now, a few ways of doing this question. The way I like to do that is I know that log base 2 of 2 is equal to 1. So I can replace that with 1. I can replace 1 with log base 2 of 2. But for the left-hand side to be equal to the right-hand side, the thing in the brackets, they have to be equal to each other. Multiply up the x plus 9, we might expand the brackets. X squared plus 10x plus 25 is equal to x plus 9, which means x squared plus 9x plus 16 is equal to 0, which of course, I think that's a perfect square. Maybe, no it's not. X is minus 9 plus or minus 9 squared minus 4 times 16. Root 17 on 2. And that's the answer, hopefully. Okay, last one. Solve log base 3 of t plus, minus log base 3 of t squared plus 4 is equal to minus 1. So, first of all, we notice that we've got the same base. So what we're going to do is we're just going to realize, okay, we can just say this is log base 3 of t on t squared minus 4. And that's equal to minus 1. We're then going to use our transformation of logs and say, okay, this is equal to t on t squared minus 4. And that's equal to, the base is 3 to the power of minus 1, which is 1/3. We might even write that. 3 to the minus 1 is 1/3. We're going to cross multiply that, so 3t is equal to t squared minus 4. We've got a cute little quadratic. 0 is t squared minus 3t minus 4. And that's, of course, going to be t minus 4, t plus 1, which means t is 4 or minus 1. Okay, I do actually have a few more and we might want to go through. Let's have a go at evaluating some of these. So let's evaluate log base 2 of 32. Well, log base 2 of 32, 32 is 2 to the power of 5. So log base 2 of 2 to the power of 5. We bring down the power, it's 5 log base 2 of 2. We know that log base 2 of 2 is 1. So the answer is 5. Next one, log base 4 of 0.25. Well, we might realise that 0.25 is 1 over 4. And 1/4 is 4 to the minus 1. Bring down the minus 1. We've got minus 1 times log base 4 of 4. And of course, log base 4 of 4 is 1, so the answer is minus 1. Part C. Log base 3 of 81, of 1 on 81 is our next question. 81 is 3 to the power of 4. So we could say this is equal to log base 3 of 1 on 3 to the power of 4. Using our negative indices, this is log base 3 of 3 to the minus 4. And now we can bring down the power. Minus 4, log base 3 of 3. And log base 3 is 1, so the answer is minus 4. Next one, log base a of a to the power of 4. We're going to use our power rule and say this is 4 log base a of a. Log base a of a is 1, so the answer is 4. Last couple, we're going to solve log base 5 of x equals minus 3. Just transforming our logs there, we're going to say x is equal to 5 is the base minus 3 is the power. So that's 1 on what? 1 on 125 would be that if you typed it into your calculator. Part B, we've got log base x of 128 is equal to 3.5. Transforming those logs there, we're going to get, oh, this is interesting. We're going to have x to the power of 3.5 is equal to 128. Now your calculator can actually take the 3.5th root of something. So x is equal to 3.5 root. There's probably an easier way that I'm too tired to know about to do that. And then we get 4. C, we've got log base 10 of x plus 4 minus log base 10 of x minus 5 is equal to 1. These are subtracting, so when we subtract logs, we're going to say we divide. And that's equal to 1. Now, yes, we could transform our logs, but we could also realise that log base 10 of 10 is equal to 1. So let's replace that with that. Now, that means this whole thing has to be 10 for those two things to be equal. So x plus 4 on x minus 5 is 10, which means x plus 4 is equal to 10x minus 50, which means that 9x is equal to 54, and that means x is equal to 6. Okay, thanks for watching. I hope that makes sense.